So in this video, what we're going to do is use the squeeze theorem to find the limit. And in particular, we're going to find the limit as x goes to 0 of x squared times the sine of 1 over x. And we can see right away that the issue is that if we try plugging 0 in to 1 over x, we get division by 0. So we get something undefined inside the sine function. So I'm going to use GeoGebra, the web-based version, to take a look at this limit. Let me get my ink pen up here. I'll need my pointer first. So the limit that we want to take, got to do this in the right steps. The limit that we want to take is the limit as x goes to 0 of x squared times the sine of 1 over x. And the sine of 1 over x, the cosine of 1 over x, those are functions we've already looked at. And the thing that we noticed for just taking right here the sine of 1 over x is that we get that wild oscillation as x goes to 0, and the limit doesn't exist because of the wild oscillation of the function as x gets closer and closer to 0. The idea is, though, that we know that the sine function by itself, if we just take the sine function, so take the sine of theta, we know that the sine of theta is always going to output a number that's between -1 and 1. So theta can be anything you want, including 1 over x. And you're multiplying, you're putting x squared here in the amplitude position on the sine function. So what you expect is, if the sine function is going to give you numbers between -1 and 1, and you're multiplying by an x squared, you expect to get x squared times that interval from -1 to 1. You expect the sine, if it's being multiplied by an x squared, to go from -1 times x squared to x squared times 1 is x squared. You expect that the sine function is going to be constrained by the parabola -x squared and x squared. And in fact, that's what you see if you look at the graph. If we turn this graph off and I graph x squared and the opposite of x squared, and then I turn on the function x squared times the sine of 1 over x squared right here, you can see that indeed x squared times the sine of 1 over x is constrained between plus or minus the parabola x squared. So we're going to be able to use the squeeze theorem to find the limit as x goes to 0. So here's the basic idea. Let's go back to the pen tool. We know that -1 is always less than or equal to the sine of x, which is always less than or equal to 1. The sine of x is always between -1 and 1. So this gives us a 3-part inequality, and what we want to do then is multiply each of the 3 parts by the same thing. We'll multiply by the parabola x squared. So we get -1 times x squared is -x squared is less than or equal to x squared times the sine of x, which is less than or equal to x squared times 1 is x squared. So we find that x squared times sine of x is between the parabola -x squared, which you see right here, and the parabola x squared, which we see right here. So the next thing that we want to do is find the limit for x squared. And what we want to recognize is that if we're taking the limit as x goes to 0 of either plus or minus x squared, it doesn't matter. We know that x squared is just a parabola, and we know that the domain of x squared is x can be any real number. It goes from -infinity to infinity. There's no restrictions on what numbers can be put into x squared. So using theorem 3.2, we can just plug 0 into x squared. We get the limit as x goes to 0. Sorry, got to go down here to the eraser. That limit is just going to equal 0 squared, which is 0. So over here, I want to recognize I have a 3-part inequality. I'm going to take the limit of each of the 3 parts. So we take the limit as x goes to 0 of -x squared, which is less than or equal to the limit as x goes to 0 of x squared sine x. Again, just doing the same thing to each of the 3 parts of the inequality. So we get the limit as x goes to 0 of x squared. And this limit, we just get to plug 0 into the x because negative x squared is defined for all x. So we get 0 squared is less than or equal to the limit we're interested in, which is the limit as x goes to 0 of x squared times the sine of x, is less than or equal to x squared is defined for all x. We just plug 0 in. So we get 0 is less than or equal to the limit as x goes to 0 of x squared sine of x is less than or equal to 0 squared is 0. So if the limit is between 0 and 0, then the limit is 0. So we can then draw our conclusion. We can say, so by the Squeeze theorem, comma, the limit we're interested in, the limit as x goes to 0 of x squared times the sine of x is equal to 0.